Okay, I'm here to talk about making legacy code delightful with state charts, which is a kind of a tough problem because legacy code is everywhere. You know, it's part of the way that we create value as developers is we sift through this code that we've never seen before, that no one knows what it does, and we work out what it does, right? And legacy code is different from unknown code. It's different from code that no one knows what it does. It's code without an organizational advocate. It's code where someone who wrote it has either moved on or they've, disappeared, or they're on a different team, or something has changed. But legacy code is incredibly tough to deal with. And I'm sure you've been in situations, I know I have, where you've just been left alone to figure out this incredibly tough thing. And usually legacy code gets rewritten or destroyed completely. And the thing about legacy code is that it's just code, but it's code where you don't understand the intent. And when you do understand the intent of legacy code, what it's trying to do, what behaviors it has, it stops being legacy. Now, legacy code in React, there's a million different ways that you could create legacy code in React. Anyone can write weird code or bad code or strange code. But I want to focus my attention on one particular part of React that does a lot of heavy lifting and can result in a lot of unreadable code, and that is the useEffect hook. The useEffect hook is really taken on the brunt of managing pretty much all side effects in vanilla React. And side effects, as Laura mentioned, kind of get a bad rap, but side effects are, talking to the database. That's technically a side effect of a pure function. Side effects are the things that your app does, and this used to be spread out in component lifecycle methods, but these are really no longer in vogue. So useEffect is really the place that we do all of our side effect management and orchestration. And let's look at an example here. And when we look at this example, I want you to kind of imagine really picture the way that you're processing this code. What are you looking at first? How are you breaking it down? What's your process for taking legacy code and turning it into code? So we have this here. What I notice myself doing, first of all, is I look at the names of things. We have this Pokemon fetcher just here. What I like to do is look at the props interfaces first. So we've got an ID coming down, and we have this Pokemon data and type data. So we understand all the dependencies of our process now. We have an ID, Pokemon data, and type data. Cool. Let's go on to the first useEffect. The first useEffect here, if there is Pokemon data, then we fetch the Pokemon type with Pokemon data.typeID and then set the Pokemon type data. Okay, so Pokemon data starts out undefined. So this can't be the first thing that happens. Okay, let's go on to this next useEffect. This useEffect relies on the props.id, which I assume we always have, and then it sets the Pokemon data. Okay, we've got it. This thing runs first, and then this thing runs first. What's wrong with this process? What we just did there? What feels bad about that process? Well, you notice that the first thing that we had to do was scan all the dependencies. We had to go, what is in this kind of dependency soup that we're eating from? We have the ID, we have the Pokemon data, Pokemon type data. All that stuff could be influencing our app. Then you need to dive into all the implementation details. You need to look at all of the dependencies of the useEffect. You need to look at what they're doing just in order to understand what the app is doing. And then finally, the intent of the code becomes clear. You have to dive into the implementation details first, and then you understand the intent. So, is this process delightful? No, it's crap. It's really rubbish. Because you really, it just takes a long time and a lot of taxing mental effort. And what you need to do is so abstract and so disconnected from what you want to do, which is just understand what this code is doing. So let's do it again, but harder. With this one, we're looking at some code which is to do with an async load video. This is the behavior that I made here. Notice that it's in a loading state first, and then it loads the image, and then when you mouse over it, the image fades away and the video plays. And when you mouse away, the video stops playing, kind of like a Netflix thing. If you want to, you can pause this talk and you can go to my GitHub repo, which is Matt Pocock react-finland-talk, and you can have a look and see if you can work out the intent of the code. So ready? Pause the video now. 3, 2, 1, go. We're back in the room. Let's do the same thing as we did last time. Let's look at the props declarations first. We have video source, background image source is hovered and is on screen in the props declarations. Then we have whether the video is loaded and the image is loaded in the state, and we have a ref. Okay, so is hovered and is on screen seem important. Then we can jump to the end here because we have like a return statement, which has, if the image has or rather, if the image hasn't loaded, then return this loading div here. Okay, but if the image has loaded, then we can safely show the image, and it's hidden if it's hovered and the video has loaded. Okay. So we've got this sense of the image loading being important and the video loading being important. I wonder how those flick to true, because here they start as false. So we have a useEffect here. This is the first of 3 useEffects we have. Props.bg image and props. So if those are true, then we set the has image loaded to false. Then we load the image. So this is some async load image stuff, it looks like. And then we set has image loaded true when the image is finished loading. And the dependencies are props.bg image source and props.is on screen. So if either of those change, then this reruns. You see what I mean about this dependency soup? You know, we're just kind of, any of these props changes could result in a change. All right, so we're looking at this now. This is pretty similar to the background image source that we looked at before, except it's loading a video. And the last one here, now if props.is hovered and there is a video element and the video has loaded, so this is coming from the ref, then we play the video and then we return, so we return a callback saying to pause the video. So under these conditions, the video should play, but then we pause it afterwards. Interesting. So we have the process, I think, which is we load the image and the video at the same time. But if they're changed, if props.is on screen, then it sets it to false, I think. And if props.is hovered, then we play the video. As you can see, this problem scales with complexity. As the app gets more complex, the useEffects get bigger. The control flow is harder to work out. And I only really sort of doubled the complexity there, like twice the amount of dependencies, twice the amount of useEffects. And how do you usually mitigate it? Right? What strategies do we usually use? We usually use things like inline comments. You know, we usually say, okay, this comment here applies to this useEffect, and it does the thing and it describes the conditions. This is pretty good. Sometimes code comments are completely necessary. Sometimes they're they absolutely save a line of code where you just couldn't understand it at all. But really, you're just improving the flow that you've had already. The flow that we've described here is bottom up. You're having to read the implementation first and then understand the intent. But really, inline comments just sort of make that process faster instead of changing it completely. So, and of course, inline comments can go out of date. You know, you can basically just have a comment there that was written 4 years ago and the code changed multiple times since then and it's completely out of date. The kind of same rule is true for external documentation, for docs that are external from the code. Although they can be kind of useful, you know, like if you have a markdown file understanding like that describes a whole set of code coverage and that sort of thing, then you do get a top-down view of what is changing in your application or what your app is supposed to do. But, you know, most of the time people don't update those in pull requests, or they're even further abstracted away from the code than inline comments are. So easy to notice when you don't update a markdown file or something similar. And the third way to make this process easier is through abstractions. You know, hooks and useEffect is really great for this because you could potentially just wrap a whole bunch of those useEffects into a useLoadVideo hook. And when the video has loaded, then you can show that on the screen. So again, I think this is the second best way to tackle this problem, but really you're still sitting in the same dependency soup. You still have to track video source and when it changes, and track is on screen and when it changes. And you're now splitting out the problem into multiple modules, which can be good and can be bad. So abstractions, I do think they're quite a good way, but again, things are still bottom up. It's kind of like an inline code comment, but better, more modular. But I think we can do better than this. The solution that we'd need, if we were to find a solution, would be a kind of top-down documentation approach where you had the intent come before the implementation, and that never got out of sync with the code, that was always guaranteed to be in sync. And that solution is statecharts. So what I've done is I've built if we go all the way back to this here, I've built a statechart implementation of this. You can see that there are multiple finite states that we can understand here. There is a finite state when it's loading the image at the start. There's a finite state when it has the image. And then there's a state when it's hovered and unhovered. Let's have a look at what that looks like in a state chart. Boom. So this code is, as Laura described, runnable. It's an executable state chart. We have specific events in here for when the video source changes and when the image source changes. And we have other events for when the image has finished loading. And when it has finished loading, we go into this loading video state. We have mouse over and mouse out here. And we have events for when the video loads and when the video load is complete, and even when the video load errors. And right here, you immediately see the intent of the code. It's right there for you before you've even looked at a line of code. This is the implementation, but it's also abstracted away from the implementation. And really, it's intent first, implementation second. What this means is if there's a bug in in the load video bit here, and you're getting some error message which says, there's a bug in the invocation inside machine video.loading or something. That's a very typical XDay error message. Then you know that you don't need to touch anything else inside the app. All you need to touch is this video loading area, and you instantly know how it connects to everything else. So the next thing is explicit events are kind of easier to think about and track than implicit dependencies. When you have these kind of implicit dependencies all over the place, like these things here, you're just sitting in this dependency soup and you're waiting for things to change. When props.is is hovered changes, how do you track that through your application? What happens when you're on this one, for example, and is on screen changes, but the video source doesn't change? It's really, really hard to derive intent from those changes. Whereas intent in these events is incredibly easy to derive. You understand instantly what these events are, and you understand immediately kind of what they're reporting on when it's built well. So they're so much easier to track, and it makes understanding the intent of legacy code a lot easier. And finally, the most important thing is that the diagram doesn't represent the code. The diagram is the code. It's runnable. There's no separation at all between your comments or the documentation and the code. Like, we rely on documentation so much for the libraries that we rely on every day, React and Xdate and all of these things. If that documentation goes out of date, it can be disastrous. It can lead to a production bug. So why don't we treat the documentation that we produce ourselves with the same vigor? The really exciting thing for me about this is that it turns your code from just code into code that's statically analyzable. You can really just use tools to peer into your code, understand everything that's going wrong or going on. And at Statically, we're building tools to help you do that and to make these incredibly rich experiences so that you can make legacy code delightful. The main thing that comes out of this, we'll probably talk and answer questions about this in a minute, like all of the implications of statically analyzable code. But the main thing is you produce code that can speak for itself, code that can allow you to read into its intent instantly without you having to do any extra work, without anyone having to do any extra work. And it democratizes the consumption of code so that you can, anyone can read your code and understand what it does. if you build a system for someone and then your team gets sent away or something, and then you have maybe a non-technical person who's just dealing with all of this code, I mean, surely they want to understand it and read it, and if they're not coding people themselves, they want to understand the intent of it. And this is the kind of thing that XState and statecharts enable. And that's me, really. I mean, I'm so excited to talk about questions for this, because there is just so many implications of being able to peer into your code and understand what it's doing and how it works, and get all of that on the table.
All right. Thanks for the great talk. And I mean, that's difficult because we do online conference, so we don't get applause from the audience. That's at YouTube. It will be weird if everybody was clapping their hands at home. But,
I appreciate it.
We can do that as well. But now we get questions. So what kind of possibilities or tools do you see know or see for designer developer collaboration with the statecharts?
I mean, this is where we're going with Statically. I can, like, a lot of design tools these days are componentizing. Like Figma is currently starting to be built around components. Modules is starting to be heading that way too. And if we start seeing statecharts move that way, then it's going to be really, really exciting, I think, for what we can do. And I've been even thinking a lot about using statecharts for prototyping too. If you can attach like a very basic layout to a state and you understand what it's doing, then you add buttons for moving between, for firing events and things like that. I mean, there's so many cool possibilities here. Yeah.
So let's see what people are saying. So it's like great talk, or there's clapping and nice and clapping. So it's a lot of people are clapping at home right now. But this will ask more questions. Or do you have some additional thoughts on the topic to discuss?
Well, what do you guys have, Laura and Farzad? You got any questions for me?
Yeah,
we got a question.
Let you and Matty go first.
How easy is it to start replacing things in legacy code, one function component file at a time, while keeping other parts of the app legacy?
I mean, if you don't understand the intent of what a piece of code does, you probably shouldn't be changing it. When you do understand the parts of legacy code, is that you can model small things with statecharts. You can model small behaviors, and you can start to reclaim parts of your app slowly with statecharts. It doesn't need to be a big change. And so, yeah, it's about hacking down the weeds, like how else do we do these big refactors, like little bits at a time?
Yeah, it's a bit like with this, like the first thing I like to do sometimes when I have to work with code I don't know, that doesn't have tests, I start writing tests. I test the code so I can validate if I understand the code. Mm-hmm. And I guess eventually when you test enough, you could maybe start extracting some logic and maybe start pushing it around. So it's sort of, I guess the point is that when you work with legacy code, it's about understanding.
Yep.
Like understanding what you're dealing with, and then replacing the old thing with a new thing that's easier to maintain.
Well, that kind of pushing around, would you call that process delightful? It doesn't feel very delightful to me.
No, it's not delightful. No,
yeah.
It's just like improving. It's better to have code with tests than no tests.
Mm-hmm.
But
I would say it's better to have a code that tests itself.
Yeah, that's even better. Yeah, so that will be like the thing to where to go. Laura had some.
Yeah, I was just going to say that when I was watching your talk, and it made me think that really it makes it a great solution for that idea that everyone says, "Oh, I don't need to comment or document my code because you can just read it and understand what's going on," and that is so rarely actually the case. And so this is a really great way of solving that problem. Is that no, actually, this does make it much more understandable to a much wider audience as well.
For free as well,
So when it comes to testing, so like a lot of people know how to write unit tests and all this stuff, and then you get more complicated things like property-based testing, and so how does testing relate to state machines or state charts?
Well, I can say this. This is a separate talk, but if you think of a state chart like let's say we take Laura's state chart of a dog. you don't need to use that state chart to model a dog. You don't need to execute it you don't need to use it to power the dog. You can use it to assert that the dog is behaving correctly. Let's say that we have some other kind of little dog robot that's written in JavaScript or Node or whatever, and we want to assess its behavior. Well, first of all, we can use that state chart to power our tests instead of our thing, And model-based testing is a really powerful tool, and it's something that XState already offers with XState Test. There's some refactors that we want to do to that library, but I've been using it happily to test backend code before, and it's been marvelous. And front-end code.
It's a very underrated, aspect of modeling with the state charts. That is, many people think that they need to model their problems that they have in the code that needs to execute using a state machines and a state charts. But rather, you can just take your understanding and how you perceive the software works, which is usually more flat and simpler than the actual implementation. Write that in a scenario-based, a state chart, because that already gives you the upfront graph. Then you can run automated, integration tests because of that. And David also has a talk that he gave, I think, 2 years ago at React Rally that talks, you don't even have to write the integration test based on the state chart, but rather auto-generate that because you already have the graph when you were thinking about how to model it.
Mm-hmm.
David who?
Yeah.
That's a David Piano, known in the world.
I've heard of him.
Yeah, so saying to the audience that if you have any questions, just send them to us, and we get to them at the end of the session. So do you have any topics left to discuss, or shall we move to the next demonstration?
I just wanted to mention something very quickly. Maybe as JavaScript developers or generally working in the web development industry, we don't really see much refactoring or working with other engineers with different technologies. But having worked as a gaming company, people work in the gaming industry with different technologies and different game engines. And working as a web developer amongst other game developers means you really have to show the intent of your code and let other game developers reflect the business in your code and fix it for you. And the state machines has been the way for us to go with that at the company.